Good morning. Welcome back. So we will be discussing Chapter 2. Now, Chapter 2 actually is considered as one of the most important chapters to understand how the programming actually works. Although this is not a programming class, we're just learning the methodologies and some of the techniques before we get to the programming class. So hopefully in the following semester. But this particular chapter will discuss how the input, process, and output, these three important components of software development, they work. And there are some techniques initially, those will be discussed. So let's take a look at the next slide. So here we'll learn how to design a program. What is an output, input, and variables. So variables are discussed in several different slides, and we'll be discussing the right way to declare a variable and why a variable is an important part of your programming development process. How do we assign them? How do we do the calculations? How do we declare them? And there are different data types. These data types, many of them are similar in various languages such as Java, Python, and C++. And in fact, we'll be demonstrating all three languages throughout the book, specifically in this chapter. So you will understand what the code looks like in Java, Python, and C++. And I teach all three of them. So you will see that there are a lot of commonalities, a lot of things are very similar. At the same time, you'll find some differences as well. And there are different techniques to before you write the code and you process the code, you test the code. So we'll go through the prototyping, we'll talk about flowcharting, we'll talk about hand tracing, documentation, internal and external documentation. And then finally, we'll learn how to design our first program and the languages which will be used, which will you be employed in this particular chapter are Java, Python, and C++. And author does a really good job highlighting simple pieces of code in all three languages. So in that way, you can see what a program looks like in Java, for example, and Python and C++. All right, so the first step in designing a program is you learn a technique which can kind of shows you how do you write a code, how do you write certain steps in pseudocode. So we'll learn about the pseudocode techniques, and you'll probably will be doing an assignment in pseudocode as well. And how do you do some kind of graphical view of it, like a flow chart? So you will see some of the flow chart boxes. We'll learn about each purpose of each box and how the code is written. And of course, we talked about in chapter 1 about grammatical errors. We call them syntax errors. Syntax errors are the errors of that particular language, such as error in Java or C++, how to avoid those errors. And again, we are not writing the code in this class. We're just learning how what the code looks like, and we probably will be refining the code later on as well. So after the code has been written, it has been checked, and there are no errors. You run the code. There is a possibility of having logical error. In fact, there are three types of errors. One is called a syntax error, another one is a logical error, and third one is the runtime error. The logical errors are the errors in your logic. For example, you needed to multiply something by 20, for example. You accidentally put 200 or you accidentally put minus 20. That's a logical error. So although there's nothing wrong with your code, but the results will be unexpected and it could be tragic in some cases. So there are many, many cases that a satellite actually crashed and $70 million project or $100 million projects basically failed because of the logical errors. So if the logical errors exist, the program must be debugged. Debug means there's some kind of bug, there's some kind of issue. So we want to test it and ensure that code actually works. So the purpose of programming logic and design is to focus on flowcharts and pseudocode. All right, so the design is the foundation of the good program. And this actually applies to everything else in our life. In fact, when you want to complete your undergrad degree, so you must have a plan, and that plan is called a design. You must think about it. Okay, I want to divide my undergrad program into 4 years, and then 4 years, each year can be divided into 2 semesters. Each semester can be divided into weekly basis. Weekly basis you can divide into per day, and then hourly basis. So if you don't have a plan in place And at the same time, while you're trying to complete that undergrad program, you probably have some plan to work part-time or maybe full-time. You probably have some family life. You actually must have a plan or design how are you going to accomplish this one. Now, in this particular view, as you can see on this slide, the program development life cycle, as sometimes like to call it, system development life cycle, SDLC. So you design the program, you write the code, you correct the syntax errors. These are the grammatical errors. Those are the easier to find. You test the code. If you find any logical errors or runtime errors, you remove those errors, come back and redesign it. So this is a cycle. This is a cycle. This ultimately you get the desired results. Once you have the desired results, then you move on and implement that code into to that organization. So two steps in designing a program: understand the tasks, what exactly you're trying to accomplish that the program is going to perform, and what exactly your client wants, what exactly the purpose is, what is ultimately you're trying to achieve. And those could be too many goals and too many different kind of tasks. So you are coming back to the specific task. So you try to refine that specific task. Once that's working, then you can move on to the other task and determine the steps that must be taken to perform the task. For example, in fact, this is one of my favorite words. It's called algorithm. Algorithm is basically a step-by-step process to solve a problem. And in fact, you are currently in college. That's what you're trying to do. You're trying to become a problem solver. Remember, a few years from now, everything will be done by our AI, artificial intelligence. So in fact, most of the white collar jobs might not be applicable at all. So, but if you're a problem solver, you will be employed. But if you're not a problem solver, you have not developed an algorithm. Algorithm is basically a step-by-step process to solve a problem. If you have not developed the critical thinking, problem solving skills, you probably will have a very difficult time. So the same thing applies here. So when you're writing a code, you're basically learning how to have refined algorithm. And for that, you use different types of techniques, such as flowcharts and pseudocode. And we'll see that in this slide here. So pseudocode is not a real code. It's not a code written in Java, C++, C Sharp, or any other programming language. It's a code written plain English. And it doesn't have to have any specific grammatical rules to be followed, doesn't have to have periods at the end. It's just a fake code used as a model for programs. So there are no rules to be followed, although we've tried to make it readable. So if I look at your pseudocode, I can understand your ultimate goal to complete the task. It should be well written. It should be easily understood by the reader and translated easily into actual code into, if I look at your pseudocode, I can convert it into C++ or Java or Python. So for example, take a look at this pseudocode here. It says display, enter the number of hours. So you can see this is not a language statement. This is not specific from any programming language, but the reader understands that anything in double quotes, we are trying to display or print that on the screen. So this is an example of pseudocode. Then it says take some kind of input from the user. Input is basically comes from the user or some kind of source, some kind of sensor. So you're trying to read that input from some kind of source. And then display hourly rate. Then input the hourly rate. Then you're trying to calculate something here. You're trying to take hours and rate, multiply, and save in a gross pay. Gross pay is a variable. It's a placeholder. So whatever hours given by the user over here, whatever rate given by the user over here, and then you say, I'm going to calculate the value of gross pay by multiplying these together. This is a multiplication symbol in many of these programming languages. This asterisk is a multiplication symbol. Then basically, once you have that gross pay in your hand, then you're trying to display those results back to the user. So this is a good example of a pseudocode. Now, pseudocode can also be translated into more graphical view. Graphical view is basically a flowchart. So it's a diagram that graphically depicts the steps that taken place in a program. Or you can actually convert your pseudocode into a flowchart as well. Or you can, before you write your code, You can also convert into graphical view. So it is easier that I can look at the flowchart and I can easily convert that into a programming code. You can see this is very similar to what we did earlier in the pseudocode. Display the number of hours, take the input, enter the employee's hourly rate, and take the pay rate, calculate the gross pay, display the results, and end. Notice that it starts with this kind of symbol. We'll look at that symbol in a second, and ends with this kind of symbol. So that's the start of your flowchart. That's the end of your flowchart. And it clearly says start. It clearly says end at the end. And there are different types of boxes we are using here. And the first one here, it is for start and stop. This is called terminator symbol. And the next one here is parallelogram, and this is for input and output purposes. So this is used for both purposes, for taking an input from a user and also producing an output for the user. And the symbol here, which is like a rectangle, that symbol is for processing, some kind of calculation, some kind of processing you're trying to achieve. So you can see how easily, and there are some additional symbols you will learn gradually, such as a diamond symbol and a couple of other symbols. They will be used for some kind of decision making. We'll look into those probably in the following chapter. All right, so flowchart connector symbol. Use connectors to break a flowchart into two or more smaller flowcharts and placing them side by side on the page. For example, if your flowchart is very kind of more need more explanation, or your program is very large, your flowchart is very large, so you can break out from your original flowchart. This is on the left-hand side, and you can put a connector. Connector is this symbol here. This is like a circle symbol, and then connector continues over there. And then you can see the end symbol over here. And also this is easily you can place on a paper or on a screen, especially if your flowchart is very large. Off-page connector symbol, if you have to go to the second page, you can see this is a symbol for the off-page symbol. All right. So output, input, and variables. So this discussion in the next few slides is very important, because we remember, if in chapter 1 I had indicated, the goal of a technology, the goal of a computer and a smartphone is basically take the data, process the data, produce useful information. Because we as humans, we are interested in useful information. We are not interested in bunch of numbers, raw facts and figures and numbers. We are interested, how do we process it efficiently, repeatedly, over and over again, and then we can produce the results which are beneficial. We call it information, which are beneficial for our decision making, because we are going to make decision based on the information which is produced by taking all that input and processing that input. And computers do that very efficiently. So here, your output is basically the data that is generated and displayed. So that is something I'm interested in, because that's the data. I can use the data and I can make some useful decision based on that particular data. Imagine if I say the output is the average age is, let's say in Long Beach City College, 23 years old. That is a useful information for the decision maker at Long Beach City College, because they can target or market that population segment. They can tweak their marketing according to that particular information. However, if the output was produced as, let's say, 38 is the average age, then of course their marketing will be different. So that is the information they can use to make their decision from that output. So the input is data that a program receives. And the variables are the placeholders. These are the storage location in the memory of data, memory for data. So this is for example, if the hours are provided to me by the user, I need to store those hours. If the rate is provided, I need to store that rate, so I can actually do some kind of calculations. So computer basically uses these three steps. These are the three typically the steps involved in a programming life cycle. So I shouldn't say the life cycle in a program. So input is received, and of course you can have hundreds or if not thousands of inputs. And then you do some kind of processing on that input based on the algorithm, based on some kind of logic developed by that particular organization. It is their trade secret, because it might not be available to outside world. And then you produce some kind of results, because we are interested in those results. Imagine those results are monthly bank statement, a monthly credit card statement, or it could be a transaction done at Walmart, or it could be a receipt at Starbucks. So that is the output. We as customers or we as users, we are interested in that output. All right. So take a look at this slide here. Input, processing, and output shown over here. So let's say the data comes in as hours and rate. Those are the two inputs. We do some kind of processing in there. And remember, the processing is done by CPU, and the CPU stores that result for a short time in the RAM, which is gross pay. It is stored. In some instances, I want to display it. I want to show back to the user, or I can print in a transaction, some kind of a receipt or something. So that's how it is actually done. And then there's a chart. This is called IPO chart, input processing output chart, describes the input processing and output for the people who are not technically savvy, so they can see what exactly happens in this particular program. So this chart shows me the inputs are number of hours and the rate. Processing is multiplying the number of hours and rate, and output is the gross pay. It's very simple to understand. And then you also have display is the keyword to show output to the screen. Now, display not necessarily is used by Python or Java or C++. It's just for pseudocode purposes. But these languages will have their own specific keywords or functions to display the data. We'll see that in next few minutes. All those three languages will be showing you how to display the data. And the sequence is also important. Imagine the sequence is, if you mess up the sequence, of course, the results will not be expected as desired. So you must have the proper sequence. Imagine if you are making some kind of dish, some kind of food, and the sequence is messed up in your recipe, then of course you will not be getting the desired results. So then you have different types of data. The first one is highlighted here is string literals. String literals are typically in these languages are shown in double quotes or in some cases single quotes. So I'll talk about in Python, you can show in single quotes or double quotes, but double quotes is the one which we are using in our pseudocode. So here when we say display Kate Austin, basically it's whatever it is in the double quotes, it will be displayed on the screen in the black screen over here on the right hand bottom corner. You can see it, and so on and so forth. So here, input is the keyword to take values from the user. It is usually stored in variables. For example, we display something on the screen. We say, what is your age? Then we have a variable called age. So we say input age. So whatever the data given by the user, let's say the user puts 23. So the 23 incoming data will be stored in age variable. So this input is very important. If I don't have an input variable, the value will be lost in the RAM and I will not have a way to access it. I will lose that value in the RAM. So that's why I must have some kind of variable declared so I can store that value in that particular variable. Then I can display it, I can process it, whatever I need to do. So programmers can define variables names by following rules. Of course, those are called the rules of the language. Just like in English and Spanish, we have different rules. We must follow rules in programming languages too. So typically the word used for, or the keyword we used for, I should not say the keyword, the word used for the variable must be one word. There should not be any spaces. You can actually have some kind of method. What if we want to call it hours per rate, or rate per hour, or hours per week? So in that case, you can use underscore to connect them. But you cannot have spaces, because if you have spaces for the variable name, the compiler might think that these are the 2 or 3 different words. So that's why there should not be any spaces. Generally, except the underscore. Underscore is, which you'll see that in a few minutes. Probably not, if not in this chapter, later on. Underscore is the only punctuation you can use, but anything else, they have a special meaning in a programming language. For example, comma, semicolon, plus symbol, minus symbol, all these have special meanings in that language. So you cannot use the punctuation to declare a variable. The first character cannot be a number for a variable declaration, and name of variable is something that which is useful. I should not be storing values in H, for example. H, I don't know what the H means. If I meant hours per hours per week, I should say hours per week. I should not be simply saying H. It should be meaningful as well. Variable assignment does not always have to come from a user input. It can also come from other places, like I indicated earlier. It can come from a database. It can come from sensors. So here we can also read the variable value from directly from the code. So here we set the dollars to 2.75, and then I can display that results. Then I can change the dollars values to 99.95, and I can display the results. And you can see the results are shown in the output in this blue screen here. All right, let's move on. I think I am right here. Okay, so let's move on. And then these languages, they have special symbols. These symbols are very important because they have a special meaning. Now, some symbols vary. So although this chapter is not referring over here to a specific language, but some symbols are different in different languages, in programming languages. But let's take a look at this, some of the generic symbols. So calculations are performed using math operators, source symbols, and the expression is normally stored in a variable. So this is your expression. This is your expression. Set sale equals to price minus discount. So this symbol here, this symbol means subtraction. Most of the languages recognize this symbol here as subtraction. This one is addition. And then we have multiplication, which is an asterisk right here, and division. And modulus actually varies. In different languages, it will be different. Modulus basically gives you the remainder if you divide something with something. And then exponent operator is also different in some languages. So I'll show you those later. We'll be using those particular symbols later. A variable declaration includes a variable's name and a variable's data type. Data type is important. Data type indicates what kind of data will be stored in that variable. If you don't have the data type, that compiler will not understand what kind of data. In some of the modern languages, such as Python, you do not need to provide the data type. Automatically, the language itself determines what kind of data is coming in, and it indicates the type of data. It assigns the type of data with that variable. But Java and C++, you must declare a data type that I intend to use whole numbers. I intend to use real numbers with decimal values. I intend to use strings. And there are other data types as well. This is just, and you'll see some of them in the next few slides. So this basically allows you to define the data type you intend to store in that variable. All right. So for example, here, gross pay. By the way, we don't really call real in Java and C++ because this is a pseudocode. We call it double, and you'll see the real code in a few minutes. But if I want to declare gross pay, where I can store decimal values as well, then I will call it double, not real. But here is just to sake of understanding, it's calling it real. So here I declare 1, 2, 3, 4 variables. Test1, test2, test3, average, and they're all double data type, real data type, which means all of these 4 variables have the ability to store whole numbers as well as decimal places. So then incoming data, or we are in this case, not incoming data, we are assigning the data to test1, test2, test3. Then we calculate the average and we display the average. And it shows me the average is 92.5 based on those calculations we just did. Sometimes the data type you have is a constant. Constant means something which cannot be modified. And you want to make certain things constant. For example, name of your organization. So for example, name of the maybe could be tax rate. So some values are constant. And that's generically, that's whole idea is that that value cannot be modified by that particular program. And then in that case, you will say const or constant in some programming languages. In Java and C++, you will see const, const, and it allows me to fix the value to this variable. Notice that this is all uppercase. This is like a convention in programming languages. Whenever you have a constant, you write as an uppercase. It doesn't have to be, but that's the convention when we are using. Then you also do a technique called hand tracing is a simple debugging process for locating hard to find errors in a program. And these are, we are referring to logical errors. Involves creating a chart with a column for each variable and row for each line of code. And the people who are in quality assurance or testing, they use these tools to ensure that there is a possibility of logical error. So they go and create this kind of chart and they go and test everything in order to ensure that the desired results are achieved. There are two types of documentation. One is the external documentation. External documentation, let's say you are as a developer, you want to write the documentation so people in the future or people in your teams, they can see exactly what you're trying to achieve and they can understand your code. That external documentation is also useful for the users in the future. How do you run the program and how you achieve certain results and so on and so forth. Then there's an internal documentation. Internal documentation is within your code, you write certain steps, how you're achieving those goals. So it explains, according to your book, explains how parts of the program works. So the other programmers or team members, they can see, or even when you come back to your code a few years from now, 6, 8 months from now, and you want to modify it, it will help you to understand what exactly you did in that particular step. All right, designing your first program, we are getting close to it. We'll be writing our code in different languages. Let's say, for example, in this case, calculate the batting average for any player. And these are the number of hits divided by times at bat. And what must be read from the user, what must be done for the input, and what will be the output. So you think about those things as a developer. So input is received, number of hits, number of times at bat, those are received from the user, or you have read those pieces of data from somewhere. Then the process is calculate the batting average. That's the process. Divide the number of hits by the number of times at bat and display those results as an output. And here is, you can convert that into pseudocode. Remember, this is not a real language. This is just a pseudocode. We'll see the real language just in a bit. It looks like a real language, but, and by the way, this can easily convert it into Java, C++, or Python. Within a few minutes, you can convert this into any one of those languages. But this one actually shows the pseudocode of the program we just discussed. And this is a flowchart. You start here, take some kind of you declare some kind of variables, you enter place number of hits, you take the hits, and if the program is the flowchart is too large, then you want to go to the next page, next column. Then you take those display those number of times at a bat, input at bat, and then you do some kind of calculation and display the results. So summary is what we have just talked about is IPO, input, determine the data needed for input, choose the variables, appropriate variables, determine the calculations, choose variables to store the calculations, and then produce the results. That's basically your IPO. Now, first time ever, so we'll be jumping directly to these programming languages, and you'll see your first time. Probably this is the first time for many of you in your lives. You'll see the piece of code. So this is an example of Java code. And we will not go into a lot of detail because, again, this is not a Java Intro to Java class. At Long Beach City College, we do offer all these languages. In fact, CS11 is Intro to C++ or Intro to Computer Science in C++. CS21 is Intro to Computer Science in Java, and CS31 is Intro to Computer Science in Python. I do recommend if you want to take my class. Currently, I'm teaching a bunch of CS11 classes, and I do teach Java and Python as well. But we have many, many different instructors teaching these classes. But just to understand the basic structure, when you start a Java code, this is what the Java code, initial Java structure is going to look like. Again, reminding you that this is not a programming class, so we'll not be going in a lot of detail explaining every single thing, but just in general. So this one here, the simple, this keyword simple here, not the keyword, but the simple is basically a class name. And you can see the keyword class here. And this whole thing is called the header, class header. This whole thing is called class header, but this is the name of my class. Within that particular class, There's a function called main function. This is a main function header, and you can see the main right there. How do I know it's a function? By looking at the parentheses. You can see the parentheses open and parentheses close here. This tells me this is main is a function. Function is also called a method. So this is the main method. The body of the main function or method begins here, and the body of main function ends over here. Then why do I have these curly braces? Because these curly braces indicate the starting of this particular class and the end of the particular simple class. And inside we have, and again, don't worry too much about public static void, what that means. Gradually you will understand those. But right now our focus is for these, especially these four languages. These four languages kind of belong to the same kind of family. Those languages are C, C++, Java, and C Sharp. These are kind of very similar, and you'll find their starting point is always a main function. So this is where you write your code inside the body here. So this is the body. This is the body. This is where you will be writing the code here. All right. Let's look at the example of this one. So let's take a look at this one. This class is called output. And here's my main function. Inside the main function, I have 3 lines of code. And these 3 lines of code, I'm trying to display. Remember in the pseudocode, we were using the word display. Here, we don't say display, we say print line. So this is a function in Java which allows me to print that particular line. And what it does, it displays that my major is computer science and takes you to the next line. This means carriage return, or takes you to the next line. This ln allows you to go to the next line. Then you do the same thing. You say print line. I know print line is a function because I have parentheses here and parentheses here to end. And then I say I plan to be a software developer and programming is fun. So it displays the 3 outputs based on those 3 print line functions. Notice that every statement ends with a semicolon, and this applies to C++ and many, many other languages as well. Some languages do not need these punctuation semicolon at the end, but Java, it is required. Let's move on. Let's take a look at this one. And this is also Java, and we can easily understand. In this case, it only says print, not print line. So notice that if I do that, although I had 3 statements like the previous screen, but all the results are right next to each other. It says there's no space, programming is fun, there's no line, because I did not use print line. But if I use print line, then I will have the ability to go to the next line automatically. All right, so let's talk about data types for Java data types. Again, remember, we are just learning the basic structures. We are not learning how to write the code, but there are 3 important 3 data types are discussed here. In fact, it shows you byte, short, integer, long, float, double, string, all different types. But these 3 are the most important one here. The one is called integer, int. Integer basically allows you to take whole numbers only, whole numbers such as 23. Integers do not have the ability to take 23.55. Integers are not designed for that purpose. But if you have a value which requires occasionally or sometimes or all the time some kind of decimal values, let's say 100.77, then for that distance, you must declare as a double data type. So double data type is a real value, is a value which has the ability to take decimal places as well. Then the variable for name is not a number, it's not a whole number, it's not a real number. It's basically some kind of collection of characters. Let's say for Anna, A-N-A or A-double-N-A. So you need to store that name in some kind of variable called name, and then it must be declared as a string. So string basically is a collection of characters. And again, you can see this is how you can take those. And byte takes only data for limited amount of data. Integer is the one which we use most frequently. It has you can see about minus 2 billion to plus 2 billion. Any data in that range as a whole number can be taken. On the other hand, long integer is much, much larger, very large value. So double, on the other hand, you can see very, very large number can be taken for double data type or decimal places, plus minus 1.7 times 10 to the power minus 308 to plus 308, which is a very, very, very large number. But even if you have longer than that one, we also have the ability to handle the longer data as well. And the strings are basically a collection of a bunch of characters or text. All right, let's see how do we read the data. To read the data, you can use, again, there are multiple ways you can read the data, but here we are creating a scanner object. I want to read the data for age. And so you declare this scanner function here. So, declare this keyword, which is an object, which is of this type. It has the ability to read the data. How do you read the data? So first you display the message for the user. What is your age? And this keyword, which was created over here, you say next integer. Whatever the next number entered by the user from the keyboard, it will be captured and it will be stored in the age variable. So the age which is entered by the user will be captured and stored here. Then you can display back to the user. You can say print line age. So this is what it's going to look like. What is your age? Let's say you enter 24. Enter key is hit. Once you hit the enter key, it tells you here's the value that you entered right there, and 24 will be displayed right underneath there. All right. What if you want to, like in this case, you want to, and notice that, by the way, I just want to show you, you also have to include this, import this scanner class. And I did the same thing over here. And then you are using the same one here for reading purposes. But this time you're reading the double data type. Double data type is basically your real value. So you're reading the temperature, and temperature could be in decimal places as well, like in this case, 74.5. I cannot use the integer because integers, the age was declared as an integer, as you can see. So I cannot use integer if I want to capture the data which is in decimal places. It must be declared as double data type. So that's the only difference is showing you in the screen here. And for the name, it must be declared as string. Once you declare it as a string, next line, whatever the next piece of data, as soon as it finds the enter key, then the name will be stored in the name variable. And then it displays back. All right, so some example, print line, this is a double quote closes here, and then there's a plus symbol here. Then one string. What does it mean? This is called concatenation. Concatenation means you're adding two strings together. You're not really adding them as mathematical purposes. You're just putting them together. You're joining them. So this is what the result is going to look like. You can also do that with the whole string as well as whole numbers or decimal double data type. For example, let's say the value of number is 5. Then you can say this value is plus number. Notice that there's no double quote around it because this one is a variable. So the results will be shown like this one. And again, we talked briefly about these symbols. You can use plus, minus, multiplication, division. And this is a modulus operator. Modulus operator gives you the remainder. Like in this case, the leftover will be 2 because 17 divided by 3, we know 3 times 5 is 15. So 17 minus 15 is going to give you 2 as a leftover, and then that will be the remainder. So sometimes that particular symbol, remainder or modulus symbol is very useful. Name constants. So like in this case, as I indicated earlier, typically the constants are written as uppercases. It's not required, but it's a convention declared as a double data type. And here in Java, you will say final, and it becomes your constant. Now, sometimes for internal documentation, let's say you want to write some kind of comments inside your code. So you can use slash slash, no space in between, and then you can write any kind of comment in that line. It could be the date, it could be the name of the author, it could be the name of the company. But this slash slash is only designed for one line commenting. If you want multiple line commenting, and this applies in Java, C++, C Sharp, and many other languages, slash asterisk asterisk slash. So then you can have many, many, many different lines. You can comment that way as well. All right, let's shift gears. So we just finished the Java, and let's look at what it looks like in Python. So in Python, remember we saw in Java print line, and we use a similar function, print function. And notice that it's going to be much, much easier because Python is a newer language. Some of the structures we saw in Java and some of the structure we're going to see in C++ is minimized. It's much easier to learn, much easier to use. So here, if I want to display something in Python, for example, you don't have to have a class. You don't have to have a function. You can simply say print, just like that. And you can say another print, just like that. And then the results will be displayed. Remember, if I compare the same exact thing, let's go back and let me see if I can find it. I went too far. Okay, right here and right here. There you go. Remember, this is the entire code, and we had to write this entire thing right there. The same exact thing in Java is way simpler, way simpler. Only 3 lines of code. And here you do not need to declare variable data type in Java, Python. It actually says, I'll take care of it. You don't need to tell me what kind of data it is. So here you don't have to say int. Remember in Java, we had to put int. Here simply says 25, age equals to 25, and it assigns 25 to the age. It assigns vice president title. Automatically, Python takes care of it for you. So this is what it looks like. This is a piece of code in Python. And he says, I'm 25 years old as a result. And to take the input, remember we had to use the scanner class and did all sort of additional steps. Here, take a look here. You can simply say input, enter your first name, and then it will be stored in this variable. And same thing with the last name, it will be stored in this variable. And then you display the results. How easy it is as compared to what we did in Java. And same thing here. Here, because you're taking the data, you're asking the user for hours. By default, the hours are kind of treated as strings by nature. So what it does, it converts the incoming data. Let's say somebody entered 8 hours or 40 hours, doesn't matter. It converts into whole numbers by putting int as casting, and you can cast into or convert into explicitly convert into integers, and then it will be displayed like that. Okay, you can do the same thing for the double data type or real numbers. You can simply say float, or you can say double. And these are the same symbols. So you can see we can do the addition, subtraction, multiplication, division, modulus. In Python, they use these two operators. These two operators to indicate the power sign. Okay, it varies in other languages. And also in commenting, remember in Java we saw slash slash. Here for commenting, you use number sign. So it allows you to do the commenting. All right, let's switch gears. Now we are in the last language we are going to talk about in our chapter 2 is C++. So in C++, you include a couple of things on the top. You include an input-output stream library. So this is the library you're including. Again, we will talk about these things in CS11 or CS21 or CS31. We are not spending too much time discussing what is an input stream and what is a using namespace standard STD. That's not our goal. But notice that this is also requires in C++, just like your Java. If you remember, we had to have main function. So C++ also is a starting point is where the main function is. I know it's a function by looking at the parentheses. When you see the parentheses, it means it's a function. So this is where you write your code. All right, let's write some code here. So here I say cout. Cout means console out or display. Remember in Java, we said print line or print. In Python, we said print. Here in C++, we'll say cout, and it will display hello world, and it displays right there. Okay, so some additional things we can do. This will display hello world. Right there's the output, hello and world. You can see right there, it could be done in 2 lines. Here, hello, and then it can also do this way. It can also, so same thing can be achieved in different ways. Here it's using end line. End line means like a hit enter key. So it allows you to go to the next line. We are almost done with this chapter. So just a couple of things. So it's also the data types. Remember in Python, we didn't have to worry about the data types, but in Java, C++, C Sharp, and C, and many other languages, you must have the data type. So we did the similar thing for whole numbers. We'll use int for integers. For real numbers, we'll use double. And here in C++ for string, it's lowercase s. For Java, it was uppercase s. So string is textual data. Okay, so I want to declare integer age. Then I capture the value from the user. So cin means console in. This is like your input. You capture from the user, and then you display back to the user, right? And it's going to look like this. This code will produce results like that one. It is a much longer program. Here you take the name from the user, pay rate from the user, hours from the user, and then you are displaying back to the user, displaying all that information back to the user. So all that information will be displayed back. So you take the name from the user, enter your name. Sometimes you want the full name. Full name might include the first name, middle name, last name, and all those things. So you can use a function called getLine. GetLine allows you to take multiple words, like Kate Smith in this case. The previous one, which we saw earlier, cin, this doesn't have the ability to take a full name. It only allows you to take one name at a time. And again, these are the same symbols. You can see we looked at plus, minus, multiplication, division, and modulus operation. Okay. And then constants, we can say this is the interest rate. Let's say this is the value of that interest rate. It is double and const. It's actually declared as a constant, which means this value for the interest rate is fixed now. Just like Java, we have single line commenting as well as double line commenting. And that's it. We are done with chapter number 2, and hopefully you will read the chapter, and then if you have any questions, you can always get back to me, and we'll get back to chapter 3 very shortly. Thank you. Bye-bye.